Welcome, guys. I talked with you a little bit today about some of these ideas, so I wanted to make them a part of this video as we start this new unit on polynomials and just kind of recap some of the notes I gave you and talked to you about today as we were meeting. All right, and starting this new unit. So as I mentioned on pages 2 and 3, we're not going to spend a lot of time doing these problems, but you are responsible for knowing how to do all of these problems on pages 2 and 3. So today in our meeting we talked about solving quadratics in terms of their factored form, standard form, vertex form. We kind of highlighted this idea of utilizing the quadratic formula and paying attention to this part of the quadratic formula that is underneath the square root. It's called the discriminant, and what that would mean if the discriminant was positive, if it was equal to 0, and then finally if it was negative. Okay. So this could be what the quadratic could look like if it had two solutions that were real solutions, one real solution if the discriminant is 0, or no real solutions if it is not touching or crossing the x-axis at all. And it's this particular situation right here that we were highlighting today as the possibility of running into an imaginary number. So here is the variable I that we are using to represent the square root of a -1, which can occur in as you're simplifying using the quadratic formula. So we came over here to this spot and we did a little example, and I'm just imagining that this might be where we end up with simplifying the discriminant and with our 2a value and our -b value out in front. Okay, so really what happens with the square root of a negative number is it is called an imaginary number, and you can simplify it by essentially separating the -1 from the whole number that it is being multiplied by, so kind of separating these. And when you do that, you can actually take the square root of your positive 9 and get 3. We're left with 3 times the square root of -1, and we assign this variable I to represent the value of the square root of -1. And then as you can see here, we divided 6 divided by 3 was 2, and 3 divided by 3 is just 1 I, and of course we have plus and minus, so this is 2 plus I and 2 minus I, and these are called complex conjugate pairs, or complex conjugates. Okay, so we are going to be using these as imaginary solutions when we are breaking down our polynomials. So all of these skills are going to be super important as we start to play with polynomial functions. I also did an example of completing a square with you guys today. So just a reminder, this is a different example than I used from 2b to 4b, but it works for everybody to kind of see it again. I subtracted 5 from both sides, and just as a reminder, I was taking half of my -4 to complete the square, so dividing that by 2 and squaring it. So that ends up being a positive 4 that I'm going to add on both sides to keep my equation balanced. This trinomial then factors into an x minus 2 times itself. And if we're going to continue to solve, we can write this as x minus 2 squared, take the square root of both sides of our equation. We're left with x minus 2 is equal to, when we take the square root of our 9, remember it's going to be plus and minus 3, which leads us to two separate equations, one that is x minus 2 is equal to 3, the other that is x minus 2 is equal to a negative 3. And as you add 2 to both sides here, we get our answers of negative 1 and 5. Okay, so just a little reminder about completing the square. Okay, and then because we have time in this particular little piece, this little video here, I just wanted to show you a diagram that will help you with one of your homework assignments this week. And that is with this idea of classifying polynomials. So as you take a look at this picture, this is just a really nice overview. I want you to pay particular attention to the degree, okay, and the name used for the number of terms, okay? So when we are classifying a polynomial by degree, we use words like this is a constant, or this is linear, quadratic, cubic. You've heard all of these to probably about here quite a lot. A fourth degree polynomial can be called a quartic, and you have a quintic for 5. Beyond that, you usually call it a 6th degree polynomial or a 7th degree polynomial. When you have the number of terms, right? For example, with this cubic, it could be a cubic monomial. Here would be an example of a cubic monomial if you just had 4x cubed by itself, one term, it's cubed, so it's a cubic monomial. This is a cubic trinomial that you see here because these terms are separated by addition and subtraction. Okay, this is a quartic binomial, 2 terms, but it's a 4th degree polynomial, so it's a quartic binomial. And we can classify polynomials by both their degree and the number of terms. Now, this isn't too very tricky. One thing I do want you guys to pay attention to and to know is that we are going to be seeing what are called linear factors a lot. So this is an example of a linear factor. And we are going to be breaking polynomials down. So we might have polynomials that have like a 5th degree polynomial or a 4th degree polynomial. And a lot of times what will happen is we're going to be breaking them down into what are called linear factors, okay? And our linear factors are always going to be of the form x minus h, okay? Where h is going to be a 0 or root of our function. Okay, so when the instructions call for you to break down a polynomial to a product of its linear factors, I want you to be thinking of this linear binomial x minus h. Okay, that's all for this video, guys. We'll talk about complex numbers in the next video, and hopefully this was helpful to you to just kind of know some new vocab. All right, know this, know that. You guys will be good to go.